Welcome back, Algebra 2. We're going to look at 6.3 with the introduction to rational functions. And in case you didn't know, the word rational comes from ratio, which means something over something else. So that sort of changes it. So I don't know if you've ever heard of a ratio, but that's what it is. So you can see that this is a rational function right off the bat because we have something over something else, a different number. So if you remember to find the y-intercept, I hope I've drilled this into your head enough that you know the y-intercept is when x equals 0. And so you can quickly figure out the y-intercept by plugging in 0 for both those x's. Well, think about what 0 plus 6 is, as well as 0 minus 3. We're looking at 6 divided by negative 3, which is negative 2. And so if they ask you for the x-intercept, what you have to do is think about what's the only way, and I know it tells you right here, what's the only way for a fraction to equal 0. And if you're thinking the numerator has to equal 0, that's true because 0 divided by any non-zero number, so I'm going to put b here just for some number that's not 0, then you're good. Well, that can only happen if x plus 6 equals 0. And then subtract 6 over, and you can find out that the x-intercept must equal negative 6. And you can confirm that it's the x-intercept because that's when y equals 0. And if you plug in negative 6 for both these x's, let me change colors real quick, negative 6 plus 6 over negative 6 minus 3, you get 0 divided by negative 9, and I hope you would agree that 0 divided by negative 9 would give me a y value of 0. Now the next one's a little bit trickier, but you might have been thinking about it already, is if you have an undefined value, it's setting the denominator, I'll just write denominator, set equal to 0. So that would be x minus 3, that's what's on bottom up here. And if you add 3 over, it will be x equals 3. And again, you can confirm that that's right. Again, I'll change colors. If you plug in 3 for both of those x's, you get 9 divided by 0. And if I ask you what 9 divided by 0 is, I hope you would all say undefined. A circle with a slash through it means undefined. So what does that mean for the domain? Is x cannot equal 3. And in set builder notation, if you remember that, we write our brace notation x with a bar saying that x cannot equal 3. It's the only value that is undefined. If you think back to interval notation, I might have written it this way, from negative infinity to 3, not including 3, and then from 3 to infinity. So be ready for both notations, interval and something else. So in exercise 2, you might be thinking, what we've been spending a lot of time in Algebra 2 doing certain things. And one of those things that we deal a lot with are quadratics. And that's what this next problem is getting you to do, is make that connection. And if you have an undefined value, that's setting the denominator equal to 0. And what I would do is my slide and divide technique, or if you have a different factoring technique, you could also do the quadratic formula. But make sure you understand why we're setting the denominator equal to 0. It's undefined. A rational function is undefined if you're trying to divide by 0. Well, that can only happen if the denominator equals 0. So what I would do is change colors again, slide and divide. 2 times negative 6 is negative 12. I'm thinking of factors of negative 12 that add to be 11. 12 minus 1, and then you also have to do the divide part. Just remember that 12 divided by 2 is 6, so when you factor it, it'll be x plus 6, and then this doesn't simplify, so we have to slide that 2 back. 2x minus 1, which actually works out nicely for when we solve this, because remember it's always the opposite. Negative 6, and then add 1 and divide by 2. And you can double check that my arithmetic is correct. So how do we use a graphing calculator to check this? Let me pull up a graphing calculator real quick. Just slide it over. Is go to y equals And you can hit alpha x plus 5 over 2x squared minus 11x minus, oops, that's a plus 11x. If I go to the graph, whoops, let me hit zoom 6. I forgot I have changed it. You can see at negative 6, it looks like there's not a defined value. Same with x equals 1/2. And I can confirm at negative 6 it's not a defined value, because if I hit second graph, I can go to the table and see that there's an error at negative 6. The downside is, because I'm counting by ones here, I cannot see at 1/2 that it's an undefined value. The way around that is to change your table setting. If you hit second window, you can make your table count by 0.5s. And now if I go to 1/2, I can see that there's an error there. So there's a way around it if you were interested. So that's what they meant by verify by using your calculator. So if the next one, where it's set builder notation, what's different about, let me go back for a second. Exercise 2, they want the values for x where it's undefined, so we write x equals. When we're stating the domain, though, we write x cannot equal. But the only thing that matters for rational functions is the denominator cannot equal 0. And so that's why you're going to see me take the denominator and write cannot equal 0, which is a little different from exercise 2, because if you're stating the x values where it's undefined, you write x equals, but if you're stating the domain, you write cannot equal. But either way you go about this, the factors of negative 16 that add to be negative 6 are negative 8 plus 2, but remember, the solutions to that are the opposite. That's why it's negative 2 and positive 8. Option 3. The next one is reminding you of the composition function, which I believe we did in the first semester, earlier in the school year. And so as a reminder, what you're supposed to do is g of negative 2 first. That's going to the g function and plugging in negative 2. So my encouragement for you would be to plug in negative 2 in for the g function first and figure out what that answer is. So we're looking at negative 6 minus 2 is negative 8. But now what you have to do is f of negative 8. So I'm going to the f function and plugging in negative 8 for both of those x's. So negative 16 plus 1 is negative 15. Negative 8 plus 5 is negative 3. So that very first answer, is simplifying that, would be positive 5. So just kind of going all over the place. If you do the next one, though, let me use just a different color. Again, you're doing g of 2 first. So let's do that. G of 2, 3 times 2 minus 2. So 6 minus 2 is 4. But then, just to get a different color, we're doing f of 4 now. So I'm going to the f function and plugging in 4. For both x's. So 8 plus 1 is 9, 4 plus 5 is 9, and so this final answer is 1. I'll go ahead and write it right here. I guess I could have did that with 5 with the previous problem as well. So what makes the next one more complicated, in my opinion, is you're not just taking a number and plugging it in for g, you're taking the entire function. So that 3x minus 2 is being replaced in for the x for f of x. So sometimes what you'll see me do is just rewrite f of x without the x's. And what you have to replace those x's with is the function of g, the 3x minus 2. Now I do expect you to simplify this where you can. Because what do I mean by that is you can distribute the 2 into this. So we're looking at 2 times 3x is 6x. You'd have negative 4 plus 1 would be negative 3. And in the denominator, 3x minus 2 plus 5 Well, you can combine the minus 2 plus 5 together to be plus 3. And you might be able to simplify this, but for our purposes, that's fine. For anybody that's curious, you could factor. Maybe I'll do this at the top, because you can factor out a 3 on top and bottom. And we're left with 2x minus 1. And on bottom, you would just be left with x plus 1. And the reason why that would be helpful is you can actually cancel out the 3's that are in front. So maybe I should touch base on this. Is on a multiple choice, this will actually probably be the best answer. 2x minus 1 over x plus 1. And you could confirm that this is the right answer. If you go back and plug in negative 2 in for both those x's, you'll still get 5. And 2 in for both those x's, you'll still get 1. This next one, what we're practicing is finding the inverse. And if you remember, the first step is switching x and y. So x equals y over y minus 2. So what makes this more complicated is there's 2 y's that we have to solve for y. Solve for y. So what I like to do is just put that x over 1, because a lot of students are good at cross multiplication. That's right, cross multiply. Because it's not really divide at this point. What's important though is that you know that 1 times y is y, and that you're actually doing x times the quantity of y minus 2. So it's actually xy minus 2x is equal to y. Now, why is this still a lot more work to do? Is what I would do is get the y's on the same side. So it's, how about this? I'll leave this as negative 2x. I'll rewrite this as y minus xy. So I subtracted xy over. Well, now what I can do is greatest common factor out a y. So negative 2x equals y times 1 minus x. And double check that that's correct, because if I distribute it back in, I need to be back at y minus xy. But why do we do that is now you can solve this by division. It's a multiplication problem. So you can just divide that 1 minus x over, and that's the equation that we're looking for. So if we look at the next one, really the same type of arithmetic. Do this in not that color. How about this color? There we go. X equals y plus 3 over 2y. Switch x and y. And with some practice, what you'll notice is you'll get the same thing as you cross multiply. I think at this point, and there's a lot of different ways you can do this, but I would subtract y to the left side so I can GCF out. You know you're doing this problem correctly if you get a greatest common factor. And then you can solve for y by division. And I'm more interested in this part of the answer, not so much the y equals. And if anything, what you might see me in the future do is write it as inverse notation. I'm trying to do as many problems as possible so you get good practice here. And at any point you can rewatch the video. But you're going to see me do the same thing over and over again, where I have to cross multiply, and while I'm cross multiplying I have to distribute that x to each piece. 1 times x is just x. Now at this point I would subtract y to the left side, and I would also subtract x to the right side. So I can greatest common factor a y out. And so my final answer, I'll write it as inverse notation because I prefer that anyway, is a negative x minus 1 over x minus 1. And just one more. I know I'm working through this quickly, but I wanted to have every answer for you. Switch x and y, cross multiply. I need my y's on the left side, so I'm going to subtract 2y to the left side, and while I'm at it, I'm going to add 4x to the right side. Because I only want y's on one side, everything else on the other. So I can GCF a y out. So it's a multiplication problem. So then I can just divide, and I'm switching over to inverse notation. And and I ran out of time, but you're ready for the homework.